Hi, good evening, everyone. Am I audible? Can anyone confirm? Can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, let's wait 2 minutes. I don't think a lot of people are going to join today because of Diwali, but we'll wait for 2 minutes and we'll
Ma'am,
start.
can you increase your volume?
Yeah, is this better?
Yeah, ma'am.
Okay, yeah. So I don't think a lot of people are going to join today because of the holidays. So I'll just wait for 2 more minutes and we'll start. Okay. So this is going to be the last summary session before your quiz one revision. So today we'll just start with week 5 and do a basic summary. And then from the next class onwards, it will be quiz one revision.
Ma'am, in quiz one revision, will PYQ discuss or anything else?
See, we'll have two revision sessions for quiz before quiz one. So one of them will discuss all of the summary, that is theoretical part of all the weeks, and well, in the next session, I think we'll be discussing all PYQs. Okay, so I don't see any more people joining, so let's get started. Okay, I'll share my screen. Is it visible to you? The spider terminal, is it
Ma'am,
visible to
can
you?
you please increase font size?
Yeah, I will. But the screen is visible, right?
Yeah, ma'am.
Okay. So before we start, let me ask you if any of you have any idea about what are dictionaries in Python, or if you have studied in CT, you can say in that respect also. What is a dictionary?
It's a type of collections.
Okay, yeah, and some characteristics of dictionaries.
Mutable.
Ma'am, there are keys and values.
Right. So main thing I'm looking for is that there is a key value pair, right? So all of the elements in a dictionary is of that same format, a key, and we'll have a colon after the key, and then there will be the value with regards to that particular key. And is it possible to have duplicate keys?
Maybe no.
No. Duplicate keys are not allowed, right? Because keys are the identifiers of the values. So all keys in a particular dictionary have to be unique, but the values might have duplicates among them. That is fine. So two different keys might be pointing to the same value or might have the same value stored. Right. So let's discuss some of the other collections that we have seen so far. Just a second. Okay. So we have seen lists, right? So I can take any list L, inside that I can store. Is there any constraint regarding data types? Can I store something like this also along with the numbers?
Yeah, ma'am, can store.
Right. And how, if I want to, let's say, append 5 to this list, then what is the syntax?
L dot append 5.
L dot append, and I can just add 5 here, right?
Round bracket.
And
Yeah, ma'am.
here, then you can print L and check if the value got appended or not.
In last.
Right. So append will add the value to the last. Now, similarly, we saw one more thing. So in a list, can I have duplicate values? Can I add a 1 if I write
Yes, you
L
can.
dot
You
append?
can. You can.
This is
Ma'am.
possible, right? Okay. Now, we also discussed something called sets, right? Set was discussed.
Yeah, ma'am.
So what is, how do we write a set if I want to put 1, 2, 3, 4, 5 in a set? What is the syntax of that?
Curly bracket,
Yeah.
then one word.
Right, so curly braces. So what is the difference between a list and a set?
A list has keys, but a set had no.
No,
Uh,
the space that it
Ma'am,
takes
also
to
lists
store
are
the
ordered, but
data,
set
it
are
is
not
less.
ordered.
okay, tell me this. If I write print L of 1, what will be printed?
Then 2 will be printed.
Let's remove this and then run. So 2 is printed. Now I have a set also. So can I write print S of 1?
No, ma'am. Not
No,
able to
ma'am.
write this.
This is giving a error. Why? Because we cannot pull out any value according to index in a set, right? But we can iterate through the values.
Ma'am, can
So
you please explain what is mean by subscript table?
see, set object is not subscriptable. This error is thrown, right? So this error comes because in case of a list, every element has an index attached to it, right? So the zeroth index is the element 1 in this case. But in case of a set, we don't have that. There are no indices by which we can directly access an element. But the same thing you can do in both list and set is that you can iterate through all of the elements one by one. So if I write a for loop here that, or if I write just for x in s and then I can print all of the elements, right? That is possible, but you cannot pull out individual elements based on the indices. So now when I come to dictionaries, let's take a dictionary D.
Ma'am, I want to ask, does in line number 7 you click, then it will come next line. Then you use mouse or something else to correct it.
No, no, this was shifted to next line. This is what you're asking.
Yeah, ma'am. Then you
Yeah, I
use
just
mouse,
pressed. Yeah, I just pressed enter, so I'm just taking it back.
and then how will you take out of that?
Just do backspace.
Use
Normal.
mouse.
You can do backspace on your keyboard. This is normal, right? You can just press enter and it will come to the next line. Okay. Since this is Python, so things have indentations, right? And that is very important to maintain because last class you saw that some people were getting errors because of that. Now, let's come to how to write values or key value pairs in a dictionary. Right. So let me say that I want to create a dictionary with people's names and maybe their marks. Okay. So this is an empty dictionary. Now let's say I have a student Rahul and I want to store his marks. So how will I store the marks here? Is this the correct way of writing? Can I directly write it like this? Uh,
No.
let's say 35. Is this a direct way of writing? So can I just now write print D? What will happen?
No, ma'am.
Doesn't work like that, right? So we can initialize a dictionary like this. This is an empty dictionary. Now if I want to add values to this, then the way is you will write like this. So keep a third bracket. Inside that, first you give the key. That is the name. Here the name of the student is my key. Now your key is created. Now against that key, what value you want to store? I am storing marks, so I'll store 35. Okay. Now after this, if I do this,
Ma'am, can you please
what?
explain why line number 9 not working in previous?
No, one second.
Now line number 7.
Yeah, this. Right. So now you can see that the dictionary is there. But earlier we were getting error because of that set print statement that was there. Okay. Now let me just comment these two lines and do the same thing I did previously. So here now if I write okay, this way also you can do. But the thing is that every time we won't have all of the key value pairs in the beginning, right? So we have to learn how to add new key value pairs. So the best way is that you first initialize an empty dictionary and then you one by one append the key value pairs that you want. Now the way of appending is like this. So you use the dictionary name, this is the syntax, then you put a third bracket, give your key value pair. Right. Now like this I can add as many as I want. Okay. So why we are discussing dictionaries all of a sudden? Also, can I have any other collections inside the dictionaries? Can I have a list inside a dictionary? That is also possible. Right. So if I want here, I can put like this. If I want to store Rahul's marks in, let's say, 3 different subjects, so I'll write 30, 40, 50. Okay. So now I have 2 entries in my dictionary. So for Shreya, I only have 1 mark stored. For Rahul, I have 3 marks stored in the form of a list. So lists are mutable or immutable?
Immutable.
Okay, now let's say I want to access just this mark, 50 for Rahul. Then what do I print? I'll write print D of Rahul. So this will get me to the list that is stored against that key, right? And since this is a list, so you can access elements by their indices. So this is an index 2. If I print this, this should give us the value 50. Right, so this is how you can work with dictionaries. Now, since I have already created, let me change.
Ma'am, is there any way to use multiple keys simultaneously? It's just
Multiple
like
keys you have.
Shreya, comma Rahul, and then equal to 80, comma, then
No,
in
no.
this list.
One key is to one value. Right. The key value pair forms one element. Okay. So here now let me keep this homogeneous so I can show you something else also. Let's create one more key value. Okay. So now I have 3 key value pairs in my dictionary D. Now what happens if I write print D dot keys? What will this give me? This is giving all of the keys from the dictionary, right? Dictionary keys, and it will give it in the form of a list, just like that is key function that we learned in CT. That same thing. So keys will come in the form of a list. Now again, I can do the same for print D dot values. Now I'm getting both keys and values in separate lists. One more thing that you can do is, if you want to get the key value pairs in form of tuples, then we can write print D dot items. Okay, so now all the key value pairs are coming in the form of a tuple inside a list. So these are the basic dictionary functions that you need to know. Okay. Now everyone, have you done the sorting function, how to write the sort function? It was discussed in
In list, ma'am, L dot short.
No, I am not saying that the dot sort function in Python. I'm saying if I want to write using first principles, how is that sort function actually written, right? In Python, you can easily do that dot sort, but in all programming languages, you don't have those library functions available. So you would have to know the logic. Okay, so we'll first discuss how to write a very basic sorting algorithm. Because see, when you go for next courses like PDSA, so you'll learn a lot of different sorting algorithms that exist. So a basic question that should come to your mind is, sorting means that we can either sort in ascending order or descending order, or in alphabetical order, reverse alphabetical order. So whatever we do, the sorting goal is the same, right? Either we want to sort in increasing or decreasing order. Then why do we need so many different algorithms? So if you look up what are the different sorting algorithms that are studied in general, you will see there is selection sort, insertion sort, bubble sort, merge sort, quick sort, radix sort. Lots of different algorithms are there. So why do we need so many algorithms to do this one single thing, to sort? Any idea? All of them will
To
get sorted.
speed, to do the computation in much efficient manner, be it the pace in
Correct.
which it can do or the space it may take to compute.
So our goal is that we always want to minimize the space that it takes to perform the sort, and we want to also minimize the time that it takes. That is the running time. We want to optimize these two things, right? So later on, when you go to diploma level courses, we'll discuss more about these things. That what is timing complexity. So you'll see a lot of different notations like big O, omega. All of these are timing complexity notations. So we always want to get the best timing complexity, right? But it is not always possible to get that best timing complexity for any type of sorting that we are doing with just one algorithm. So in multiple cases, multiple algorithms will give the best result, right? So we need to learn all of those algorithms and then use the one that we require based on our current problem statement. So currently we're not going into so much details. We'll just discuss what is a basic sorting algorithm, right? So if I have a list of numbers and I want to sort them, let's say in increasing order. Okay, so what is the basic way of sorting? That we find out the minimum most element, right? We first find out the minimum element in the list that is given to us. That's the jumbled list. Then you take a new list and you keep on appending that minimum element to the new list. So let's say I have 5 elements. Okay. Now from those 5 elements, I'll first pick the minimum one and I'll append it to the new list. And once I append it to new list, I will delete that element from the current list. Next, again you run the same thing. You again find the current minimum. So now the minimum has changed. Now you again pick the current minimum and you again append it to the new list. So like this, and every iteration we are just trying to find the current minimum in my original list. And every time I pick the minimum, I will move it to the new list, append it to the new list. So append means we will add from the end. So it will always be in increasing order. How long will we do this process? As long as my original list doesn't get exhausted, right? When there are no more elements, then it will automatically stop. So let's comment it first that what we are trying to do. So first thing we do is find out the minimum element. Find out the minimum element in the list. Second thing, what did I say? Append it to a new list. And third step is remove the minimum element from the original list. So this is the basic idea of how to sort. Now, all of you know how to find minimum, right? So can you give me an idea, if I have a list of 5 elements, how do I do that comparison? How do I find the minimum element? What is the starting point? Just give me the starting point.
Ma'am, first we will take the first index,
First element or first index
first
element, yeah.
element.
Then,
Then we will compare it to the others with a
right.
for loop.
So with a for loop,
And
we
check
can do
minimum.
that.
While loop.
And ma'am, check minimum.
So with every element, we are going to check if we find an element that is smaller than this first element, right? And
Yeah,
every
ma'am.
time we find that smaller element, we will update the current minimum variable. So initially, the current minimum variable will be storing the first element of the list. Then we'll run a for loop with the range as length of list. So it will go through all the elements
Ma'am,
in the list.
ma'am, in
Yeah.
case of integer, we use min value is equal to 0. But in case of alphabets, what we have to do
No,
to
it's not
define
like that.
min?
We are not defining min like that. Okay. We are going to take the minimum value as the first index element. So we can start from the first element itself. Okay. So sorting alphabetically, this thing will not work. Okay. This current algorithm that I'm writing is for numerical sorting. Alphabetic sorting is different. Okay. Define, let's call this obvious sort. So if you have watched the lectures, you will know that professor has already done all of this. So first we will take an empty list, right? This is the list that I'm building. This will contain the sorted elements. So X is an empty list. Now, How long will this procedure run? How many times will I find the minimum and append it to the new list X? As long as my original list is not empty, right? So we'll take a while loop here. So while, what should be the condition? If my original list is L, how long will it run? Until L is not empty. So the condition can be what? Length of L greater than 0.
0.
L has some element in it which we still need to sort. Then let's take a variable mini. So this will store the current minimum for every iteration. So initially in mini we'll be storing what? L of 0. Right, L of 0. Now for I in range, so we'll go through the entire list, right? So I in range, length of L. So for every iteration, what am I doing? I have to compare, right, with every element with the next. So this first element will be compared with every other element in the list. So if L of I, that is the current element, is less than mini, that is the first element. So if we find an element which is smaller than the first element, then you have to update mini. So then mini will be containing L of I, that is the current smallest element. So this, after this iteration is done, right, before you go for the next while loop iteration. So this is what? This is the inner for loop iteration. So for example, take a list of 5 elements. Now I have picked the first element, I've compared it with all the other elements. Now in mini, what is stored? The current smallest element. So next step is what? We have to append it to a new list. So come out of the inner for loop. Now you will do x dot append, and what are we appending? Mini. We also have to remove mini from the original list. So L dot remove mini. And after this is done for all of the elements, that is the while loop is exhausted, the original list is empty, then what do we have to return? Where is the sorted list stored? In which variable? Every time that I'm removing the minimum element, where, in which list am I adding it?
You're adding to X.
X. So X in turn will contain the entire sorted list. So we'll just write return X. Okay, let's see how this is working. So I'll just take a list of numbers like 77, 9, 21, 13, 56. Okay, and let's call this function now print obvious sort, and we'll pass L. This is giving in a sorted order. So what is it doing in first iteration? What is my mini? In first iteration, 77, first element. Then 77 is being compared with 9. So now you go to the inner for loop. So is 9 less than 77? Yes. So now your mini is 9. Right. Now your mini is done. Now compare the current mini with the rest of the elements. What is the next element? 21. Is 9 less than 21? Yes. So mini does not need to be updated. Mini will not be updated for any of the other iterations, right? So now which element is the minimum? 9. In the first iteration of the for loop, we found that minimum is storing 9. So you append that 9 to your X and then remove it from this list. So once 9 is removed, now in the second iteration of while loop, what is the mini? Again start from the first element, which is 77. Again compare 77 with 21. So now your 21 is in your mini variable. Then again 21 with 13. So now 13 is smaller, so that will be updated in mini. 13 and 56, 56 is not smaller, so minimum will be 13 from this iteration of the for loop. So again you now take out 13, add it to X. So 9 comma 13, and here I will remove 13. So like this I'll do for all of the elements. Is this clear procedure? Anyone has a doubt?
Ma'am, what to do when this is not the case of numbers but alphabets? A, B, C, D in list.
Let's try with alphabets. See if it works. So this particular algorithm, like I said, it is not for alphabets, right? So for alphabets, usually we use the dot sort only. So do you want to write like this obvious sort algorithm for alphabets? That is, we usually don't write that because alphabet sorting is not done in that way. I mean,
Will it be asked in the exam, ma'am?
no. Alphabet sorting we don't do.
Okay.
Mainly you do sorting for numerical values only, right? Because in a list, say, why
If
we
there
do
is a
sorting?
sentence given and if they ask us
No,
to
no,
arrange the, okay.
no. That type of questions they won't be asking. Why? See, because questions need to be meaningful, right? In a real world scenario, you won't ever have to sort a list of characters or words. That, I mean, if it doesn't give any meaningful value, but in most cases we'll be sorting it numerically. But still, just give me a second if I can show you. I had that program written. So we can do one thing. We can use the iterator. We can use the iterator if we want, and then we can use the sorted function, right? There is a function called sorted also. Okay, it's better not to do it right now, okay, since you don't know all of these things. So for now, let's just discuss this numerical sorting. After we are done with iterators, generators, I'll tell you this part, okay? It will make more sense then. Alright, this algorithm is clear for everyone?
Yes.
Yeah, ma'am.
Right. What we can do now to better this is we can write this in two different functions. Okay, now why we do that? Because instead of doing this minimum so many times, right? We can just write a separate function that will find the minimum. The only work of that function is to find the minimum and return the minimum value. So let me give this back to the original one. So now we'll write a second one. Let's call it, for now, forget about this. So let's first write a definition of a function to find the minimum element of a list. Let's call it min list. In min list, we'll take L.
Ma'am, you are writing same function in different way.
No. See, previously I did the entire sorting in one function, right? Now I'm going to use two functions to speed up the process. Okay. See, first I'm going to write a function that takes out the minimum element of a list. This function will do just that. So here also same thing. So in minimum, I'll take the L of 0 first element. Then for I in range length of L. If L of I is less than mini, and mini will be storing L of I. The same logic here, it will return mini. Okay. So now we'll write the second function, which is the actual sorting function. So let's call it sort2. This will also take that same list. Now inside this, let's get our empty list. So this is where the sorted elements will be stored. Now we'll run a while loop, same as the last one. So while How long will this run? As long as there are more elements in the original list. So as long as length of L is greater than 0. Now what I'll do is in mini variable, I'll just call this other function I wrote, min list. Okay, and we're going to pass L. Now, next things we have to do is just append mini to X, and from L we have to remove mini. And then return X. So I'll just get rid of this for now. Now let us print this. Sort 2.
Ma'am, can you please explain line number 10?
Yeah,
Mini.
I will explain the whole thing. Okay, just let me run once. Okay, so this is also working now. What I did is in line 5, this is definition of min list function. This function is dedicated to solely finding out the minimum element of a list. Now in the actual sort function, we did everything same as the last one. We have an empty list, we are running the while loop. But inside, previously I had the mini function written here, right? It was not a separate function, we just wrote the code in the sorted function itself. But here I just, in the mini variable, for every while loop iteration, I have to find the minimum of the current list, right? So I'm just calling this min list function and it will do that for me. So every time I come to line 15, the control will shift to the definition of this function, min list, right? And it will find out for this same L, right? Every time I find the minimum element, I am appending it to X and removing it from L. So L is going to be a new list every time we finish an iteration of the while loop, right? L is not same as before, an element has been removed. So how many times, for this particular example, how many times will min list be called?
Ma'am, one I have a doubt. Line number 17, L dot remove works for mini
Hmm.
above one.
So why?
Line number 5.
Didn't understand. This line you didn't get?
Yeah,
L dot
ma'am.
remove?
That remove happens to above list also. I mean list.
L list. Only the original list. So what is the procedure I wrote here? First we have to find out the minimum element in the list, append it to a new list, and then remove the minimum element from the current list. So that when we go for the next iteration, we don't pick the same element, right? Every time you pick a minimum, you have to remove it from the list so that next time you pick the next minimum. That's what I'm doing. In every iteration of while loop, mini will contain what? The current minimum of the list. Once we find the current minimum, we'll append it to X and remove that minimum element from L. Now for next iteration, when you go, like in the first iteration, current minimum will be 9. So 9 will be appended to X and removed from L. Then in the next iteration, minimum will be 13. 13 will be appended to X, removed from L. Like this. So that's what I'm asking, that how many times will this min list be called for this example?
Ma'am, I don't able to understand L dot remove. It
L
will
dot remove
remove
just removes the minimum element from the list L.
just like 9 is also removed from list that is for line number 5.
Line number 5.
Yeah, ma'am.
This doesn't
That's
remove
mean,
anything.
ma'am, I am able to understand that it will return mini only one value.
Yeah.
That will be stored in line number 15. Then it will be appended to line number 16, X list.
Hmm. And
Then
from the
this
original
will,
L list, we will remove that value because now we
yeah,
already have that minimum.
then we again move to line number 5, mini L equal to 0.
No,
Then,
no. This control, see, here once you remove, for in our example, in first iteration, you'll be removing 9, right? The smallest element. Once 9 is removed, now your L list contains what? The other 4 elements. So now go for the while loop second iteration. Then you again have to find the minimum. So now your control will again shift to line 5. See, we are
not
doing while
directly
loop
to line
iteration.
5.
No, no. This is how you call a function within another function, right? So you have to understand the control flow. So we are see here when I write print, which function am I calling? Mini or sort?
Ma'am, sort.
Sort, right? So this is the function I'm calling sort to. Now inside sort to, I am using one more function called minList. So first of all, I'm calling sort to, right? So this will run. Now inside sort to, I have a while loop. So every time, for every iteration of the while loop, the minList function will be called, right, to find the current minimum. But not directly. For every iteration, you first have to check this condition that length of L is still greater than 0. That is, there are still elements in your original list. Then you will find the current minimum in your list. Then append, then remove. Then again go for the next iteration of while loop and check the length of L. Then again call the minList function, get the minimum, append it, remove it. Like this.
Ma'am, so that you explained that from line number 17, we have to move line number 14, then
Yes.
15, then 15 to 5.
Yes.
Okay, ma'am. Thank you,
Wherever
ma'am.
you are calling the function, at that point the control will shift to the definition of that function. Okay, so this is the function call in line 15. This is the function definition in line 5. This part is clear for everyone? Sorting?
You asked a question how many times the
Yeah.
minList function will be executed. I am of the understanding it will be equal to the length of the list L.
Length of the list. Correct. Because for every element I have to check, right? Even if there is one element, I'll still have to check what is the minimum, even though that is the minimum.
Ma'am, it is not fine that it is less than length of 1.
No. Less than length of
Last
1.
one we have to not check.
No, we do what? That as long as the list is not empty. So that's why the condition is that as long as there are elements in the list, so greater than 0, that there is at least one element. Instead of going at most, it is better to go at least, right? In this condition, whenever we check for non-empty, that's what we check, that length is greater than 0. You can write it in a different way also if you want, but this is the standard way of writing when you're checking if a list is empty or not. Or you can also use is empty, obviously. Okay, now this part was easy. Next thing that we have to discuss is the matrix multiplication part. Any more question from here?
Ma'am,
Yeah.
ma'am, how do we know which data type is mutable or which data type? I am difficulty remembering all these things.
Ma'am,
And
I have
which
to
commands
take
are
a
applicable to?
screenshot. Please
Which
show
commands are
from
applicable
5 to
to?
19.
1 minute, Manjeet. Which commands are applicable to list and which commands are applicable to like tuple and set? All this getting mixed up.
Yeah, see, so best way of remembering is that you have to practice programs with each of the different collections, right? So some things are mutable, some things are non-mutable, a lot of different things are there in Python. So if you can't remember, make a list of it. Also there are slides that we have used in the session, so you can use those slides also. There it is clearly mentioned which one is mutable, which one is immutable. But these list functions or dictionary functions, these are unique functions to a particular collection, right? So you have to remember these things. Like append cannot be used for all of the collections.
Yes, ma'am.
Okay, so there is no other easier way of doing this. You either have to practice or you have to memorize.
Okay, ma'am. Okay, thank you.
Okay, so before we go for the code of matrix multiplication, so you can tell me how to multiply two matrices. If I have two matrices like this, okay. Let me write in the PDF.
And while you are bringing that on screen, just a generic question. You started off with the dictionaries and then you moved into sorting and now matrix multiplication. Will you continue back again on the dictionaries or
No. See, that was just part of the collections. Okay, so after dictionary, collections are over. So now we have to move on to next things like this, and then we have iterators, generators, lambda functions, these parts. So collection is over with dictionaries. List, set, tuple, dictionary, these are part of collections.
Okay.
Ma'am, can you elaborate dictionary?
But I will, if I take the next class, I will try to do some problems on dictionaries, right? You can also solve some of the PYQs of OP questions on dictionaries. Uh, 1 second. Okay. Can you see the PDF? PDF is visible to you?
Yeah, ma'am.
Okay.
Yes, ma'am.
Okay, now see. If I have two matrices A and B. Okay, matrix A has these values 1, 2, 3, 4, 5, 6, 7, 8, 9. B has 10, 11, 12, 13, 14, 15, 16, 17, 18. So if I want to do A cross B, then it should give me another matrix C. First tell me, what is the dimension of A or B?
3 cross 3.
The dimension is 3. These are square matrices, right? So we'll say these are 3 cross 3 matrices. Square matrix means what? Same number of rows, same number of columns. Now, if I want to do matrix multiplication, the resultant matrix should also be of the same dimension, right? A 3 cross 3 matrix. So, how will I form this? If I want to find this value, what will come over here?
It's
Then
a summation of
One
AI
multiplied by 10.
J.
so basically it's a dot product, right? It's a dot product of the first row here along with the first column here. So if I do 1 into 10 plus 2 into 13
Yeah.
plus 3 into 16. So this is 10 plus 26 plus 48. That is 84. So this will come over here, right? So this is a dot product. Similarly, if I randomly want to find, okay, first tell me what is the index here. If I start indexing with 0, this is 0th row, first row, second row, this is 0th column, first column, second column. If I want to find what will come over here, let's say. So
1, 2.
what row is this? Row 1, so P of 1, and what is the column? 2.
2.
So at this place, what value should come?
80. Sorry.
So we will find this out because we know the row, first row, right? Row number 1. That is actually the second row. This is 0th row, first row, second. Okay, so then we need to take this row, row number 1, and multiply it with which column? Column number 2,
Mhm.
right? So just match the rows and columns. So like this, we can populate this entire C matrix. The matrix multiplication everyone understands, right?
Yeah.
The simple dot product. Now our job is to convert this into a program.
Okay.
Ma'am, you simply use 1 and 2. We need not to define A and B.
Everything I have to define, right? When I write the program, I will define. This is just the mathematics of it, that how to find it. Okay, so usually in Python, we are always going to start from index 0. See, if I want to write this, first let's write it in the naive way. Okay, we'll just write all of this in one single flow, no different functions or anything. So let's first write all of the different rows. So first row is 1, 2, 3. This is the first matrix I'm writing. Okay, so R1 is 1, 2, 3.
Ma'am, we are still seeing the PDF in case if you are.
Oh, okay, I'm sorry. This is okay?
Yes, this is fine.
Okay, now see. Second row of my first matrix is 4, 5, 6. Third row are 3, 7, 8, 9. This is my first matrix. All 3 rows are done. Now for second matrix, let's call it row S1. Let's give it 1, 2, 1, S2, 6, 2, 3, and S3, 4, 2, 1. So these are our 2 matrices. Okay, so now we'll take 2 empty lists. One is A and B. Now why I have this empty list? Because here the matrix representation we are going to use is in the form of list of lists, right? So this A is the actual matrix A. Inside that there are 3 rows, R1, R2, R3. Okay, B is the matrix B, inside which there are 3 rows, S1, S2, S3. So I can simply write A dot append R1. So your first row is appended. A dot append R2 and A dot append R3. Done. Similarly do for B. B dot
We can
append.
use extend and add all the 3 rows in one shot, isn't it?
Yeah, we can do that also. I'm just trying not to complicate anything, so I'm writing in a very naive way. Okay, we can do that. Extend it. So let's add all 3 rows, then we'll write the logic. S3. Okay, now all 3 rows are added for both the matrices. Now we need a third matrix which will store the product matrix, right? So it also needs to have the same dimension, but currently we are not going to bother much about the dimension and everything. We'll just directly write it like this, that initially let's have all values as zeros. Okay, when we actually write it in the form of a function, then I'm going to use a function for everything, creating the matrix and everything, but this is the naive way. Okay, now 3 rows I am having in the resultant matrix because it has to be of the same dimension and all values are 0 initially. Okay, now let's take a variable called dimension, which stores the dimension of the matrices. As we know, it is 3. Okay. So now we will go through each of the matrices with a single variable. Right? We'll take I and j. Okay, first I variable is for the row, j variable is for the column. So how many rows and columns are there? 3 rows are there, 3 columns are there in each of the matrices. Right? So let's start writing the for loops. So for I in range dimension. Dimension is 3, so there are 3 rows, it will go from I0, 1, 2. Right. Now let's take a j value. So for j in range, again dimension. Now we'll take another for loop k. For k in range, so I'll explain this why I'm taking this k dimension. First let's write the logic. C of ij. This is what I want to find, right? C of ij. Like in the example I showed you that if I had C of 1, 2. Right, how to find C of 1, 2? You take row number 1 from matrix A and column number 2 from matrix B and do a dot product. So for any ij like that, so C of ij will be what?
1, 1.
Let's say, for example, let's say I is 1, j is 2. In that case, you need the first row of matrix, second row of matrix A and third column of matrix B, right? If I is 1, j is 2. So how do I get that? How do I get the row number 1 from matrix A, that is this row? We have to generalize it. see, can I write it like this? A of I K, okay, star B of K J. Can I write this? Why am I doing this? See, if I is 1, J is 2. Think of it like this, okay? If I is 1, J is 2. In that case, in the first iteration, okay, there are two nested for loops, keep in mind. So this inner for loop will execute first. So we know I is 1, J is 2. For that iteration, A of I means A of 1 and K values will change from which to which? 0 up to 2. Right, so I will get A of 1 0, A of 1 1, A of 1 2. That means all three elements of the first row. Look, I will do one thing. Let's relate it to the example first.
Ma'am, able to understand after equal to symbol, but Cij not able to understand.
Wait, I'll just relate it to the example. Okay, then it will be easier. See here. When I write C of ij, right, we are trying to find every C of ij. So for example, if currently in my current iteration, I'm trying to find C of 1, 2. That means what? This row and this column dot product. Yes? This much is clear?
Yeah, ma'am.
Okay. So first I have to extract this row and this column, right? All of the elements from this row and column individually. So for that, I am writing A of I K into B of K J. Now let's see what all values they can take. So I value is fixed, it will be 1. J value is fixed, it will be 2. But K value can take 3 different values, 0, 1 and 2. Here also 0, 1 and 2. So for first iteration, the K value is 0, right? That means A of 1, 0, star B of 0, 2. Which are those elements? What is A of 1, 0? Row 1, 0th index, 4. What is B of 0, 2? Row 1,
10.
third column, column 2, right?
Oh, column. Yeah, sorry, ma'am.
First index is for row, second index is for column. So row 0, column 2, that is this element, 12. So 4 cross 12. Okay, this is the first thing you got, which is 48. Now we are doing dot product. So next product will be between whom? 5 here and 15 here. Yes or no?
Yes, ma'am.
Okay, that means now tell me the indices. To get 5, what is the index? I value is same. K value will now be 1. So 1, 1, and K value here also incremented to 1, 1, 2. This is the next iteration. So A of 1, 1 is 5. B of 1, 2 is 15. So now you have 5 into 15. Now for the third iteration of the innermost for loop, that is K loop, what value will K take? 2. So now remember, ij values remain same. So A of 1, K value is 2. So A12 is row 1, column 2, that is 6, into B of 2, 2, that is row 2, column 2, that is 18. So 6 cross 18. Now I need what? Summation of these three products, right? So 48 plus 75 plus this one, 108. So now look at the code. Wait, let me share the entire screen. 1 second.
Ma'am,
Yeah.
is there any predefined function for doing these operations? That is,
Yeah, you can use NumPy. Okay. You can use the NumPy library, but that's not the point. We are trying to see how to write it ourselves to build the logic.
Ma'am, can you please explain how we understand we are doing AB multiplication, not BA?
Because that's how I've written, right? In the code, have I written B of ik? No, I've written A of ik. That means A is the first matrix, A is the left-hand matrix. If you want to do it BA, then it will be B of ik, A of kj. Right? Then you pick the row from B matrix, column from A matrix. The opposite.
Yeah, ma'am. Thank you, ma'am. That is my doubt.
Yeah. See, now, can you understand that in this part, I will be getting all of the products ready if I want to find C12. In that case, all three products will be calculated in this part. Is that clear?
Yeah, ma'am.
But we have to find summation of products, right? That means we have to add the products after every iteration. So simply what we can do is write here C of ij plus this product. Sorry. C of ij, and this is A of ik. Plus this product, we can write it like this. That means after every time a product is calculated, we are going to add it to the current Cij value. So all three products are going to be added to the current Cij value. Cij values are all initialized to 0, right? So first you add the product that we calculated. First product was this 4 into 12, that is 48. Then 5 into 75, so 48 plus 75. Then that summation plus the next product, like this. How long will this continue? As long as k is in the range. So this inner for loop is to change the k values. So how many such multiplications do I have to do to get all 9 values of this C matrix? See, to get one value, how many multiplications did we have to do for one Cij?
3.
3 products, right? So for 9 such values, we need 27 such products, right? So I is for the row, J is for the column, K is to travel within the row and column, right? For example, think of it like this. First iteration, I will be what? 0, 1, 2. What will be I? First iteration. Dimension is 3. For I in range 3, what is the first I value?
I value will be 0.
0. Then go for the next for loop, inner for loop. For j in range 3, what is the first j value?
0.
0.
0. So I and j are 0, 0. Now for k in range dimension, what is the first k value?
0.
0. Okay. So that means I am trying to find C of 0, 0. That means this one. This. Right. Row 0, column 0. This value I'm trying to find. So for this, which all products do I need? What will be A of ik into B of kj? Start, you know that I is 0, j is 0. Now the innermost for loop for k is iterating. First k value you said is 0. That means I need A00 into B00. What is that? What is A00? In this
1.
example?
1.
1. What is B00?
10.
10. So this product is 1 into 10. Okay. Once this is done, this is stored in where?
Cij.
C of
C.
00. So C00 is currently 10. Go for the next k iteration. Now k value changes from 0 to 1. So next iteration, we are calculating the product A of 0, 1 into B of 1, 0. What is A of 0, 1?
2.
2. What is B of 1, 0?
11.
11. So 2 into 11. Where is this being stored? This 22. It will be added to C of 0, 0. So this will be 10 plus 22 now. That is 32. Right. Again go for the next k value. So k value will now be, for the third iteration, 2. So we are calculating product for A02.
I'm sorry,
B.
just a minor correction. If you can scroll up on the B matrix. So for
Sorry, this will be 13, right?
13, 13.
We
Yes, sorry.
did 11. Yeah. This will be 13. Thank you. $26. This is 36. Okay. Now A02 is which value? 3. A20 is which value? 16. So now the current product is 3 into 16. That is 48. It is stored where? Again add it to the current C00, which is 36 already. So 36 plus 48 now. This is 84. This is your C00. Now one value of the product matrix is calculated. Again, now when you go for the next iteration, now I value will be changed or J value will be changed. You have nested for loops. So the one time the innermost for loop K is exhausted. Next, you will do what? Second iteration of J for loop.
Then J, ma'am. J is equal
So
to
J
1.
will now change to 1. So next we will be finding for Cij, that is C01. Right? And same thing you will do, change all the K values and just find the product. And
Can you explain this again? I've become confused.
from which part? From this J
From
value?
this, from I value 0, then J 0, then K will
This
vary
was the
from.
first iteration, right? See,
Yes,
first iteration I is 0. For that we are coming into the inner for loop, which is J. For that also the first iteration J is also 0. Now coming to the innermost for loop K. Here K starts from 0, then goes to 1, then goes to 2. Once inner for loop is exhausted, then you come back to the outer for loop, that is for J. So now J value is not exhausted yet. J can still go up to 1 and 2. So go for the next J iteration, that is 1. Again come into the innermost for loop K. It will again iterate 3 times, 0, 1, 2, 3 K values. Once that is exhausted, again go back to J. Now J is 2. Again for J value 2, K will iterate 3 times, 0, 1, 2. Now J is also exhausted. So go back to the outermost for loop I, which was 0 all this time. Now I will change to 1. Okay, and just do the same process all over again.
Then 27 times.
27 multiplications will be there. Yeah.
So, ma'am, each term of multiplication will denote what? That
Each multiplication denotes that we are doing the dot product to find one particular entry in the resultant matrix.
we have 9 entries in the resultant matrix.
We have 9 entries. To find each of the entries, we need 3 multiplications like this AIK into BKJ.
So the one entry is obtained by the inner
3 multiplications. Yes, the innermost one is the one where the calculation is happening. See, this is to traverse both the matrices simultaneously. Okay, I is for the row variable, J is for the column variable. Now inside the row and column also you have to traverse, right? The first element, the second element, the third element. To traverse that you have the K variable. So for every I iteration, J will iterate 3 times. And for every J iteration, K will iterate 3 times. Understand? So for one I value, there will be 9 iterations.
Ma'am, why we are taking K variable? I and J are for columns, rows and columns, and so
okay.
K we are taking.
I and J are for rows and columns, right? So I want to find for 0th row, 0th column, that is C of 0, 0. So for that I need to find the dot product. Here I want to find this C of 0, 0. I and J are both zeros. So how do you find the dot product? You have to multiply this 0th row with the 0th column here, right? But you have to traverse the elements inside them also. So by only 0, 0 can you traverse?
No, ma'am.
A0, you first need to start with A0, 0, then A01, then A02. So to do this 0, 1, 2, we need a third variable, which is not fixed, which is iterating, that is K. Same for B, we'll start from 0, 0, then B, 1, 0, then B, 2, 0. Here this is the K.
Okay,
this
fine.
is I, this is J. Understood?
How do we do this matrix multiplication for a rectangular matrices?
Rectangular matrices also, see that there the dimensions change, right? But the code will work.
Yeah.
Here, the I, J, K, everything is depending on the dimension, right? So there you will have to have separate dimensions.
Okay.
Okay,
So
you
here
can
you
assign
took
it
the
to one,
dimension
two.
as 3. Is it because of the keeping
Because
the
these are
resultant
square
matrix?
matrices. Yeah,
Yeah.
square matrix multiplication will always give the same dimension square matrix.
Okay.
Okay.
Ma'am,
We are only
how
going to
did
do square
last line
matrix.
work?
Which line?
Addition, ma'am, addition, last line in code.
Okay, this one. This. Line 27, right? So
Yeah,
every
ma'am.
time you calculate a product, dot product means what? Sum of products. So every time a product is calculated, you add it to the current Cij. Like here, when I'm doing C00, first product is what? A00, B00, right? That is 1 and 10. So this product is now stored in here. Next product you calculate is A01, B10. That is 2 and 13. So this 26, but 26 has to be added to C00, right? So current C00, which is 10, plus the product, that is 26. That's why this line of code, that every iteration you add to the current Cij. Got it?
We have to change ij value to add it in another value.
No, Ij value will not change. No, you're just adding the products
Ma'am,
to form the dot product.
400,
Hmm.
ma'am, 400, all the values of A0 and BKJ0, we have to store in C00.
See,
If
understand
it
the
is
iteration.
C01, then we have to use another way.
Yeah, if it is
We have to
C01
store all 0k values into
with
BK02 values into C02.
Ij is always fixed. Okay. For every iteration, we are just for every I iteration, and we are just trying to find an Ij value. So we'll start with 00, then 01, then 02, then 10, 11, 12. But for each of these values, each of the Cij values that we're calculating, for that we need 3 multiplications, right? Since this is a dimension 3 matrix, in each row and each column there are 3 values. So to find every Cij value, you need to find the product of 3 such multiplications, and you have to add them to get the dot product. Okay, that addition is happening here in line 27, that every time I'm calculating a product, I'm adding it to the current Cij.
Ma'am, would have been a little better if it was Cij plus equals to
Same
instead of.
thing. You can write plus equal to, or you can write it on the right hand side. It's the same thing. In fact, this is easier to understand because you can see the addition happening. If I write plus equal to, people will be even more confused. Right?
Okay.
Because a lot of people don't use that notation. But same thing, you can use plus equal to also. Basically, see, Cij is a constantly changing value as long as k is running. Right? As soon as k is exhausted, the current Cij is closed. But every time k is running, for every k iteration, we are finding one product, this aik bkj. This product has to be kept, we have to keep on adding this product to the current Cij as long as k is not exhausted. And then we change the j value. Once j is exhausted, then you change the I value. Is it clear for everyone?
Yes, ma'am.
See, this matrix multiplication is a little bit difficult to understand on the first go, right? So you do this dry run by yourself that I wrote. Just write 2 matrices and see how each line of the code corresponds to it.
Ma'am, you have written this with the for loop, right? But we can use the other loop.
Can you
You
please
want to
explain with while loop?
while loop? I am not going to bring into this mix because already there's a lot of confusion, and usually this type of code you write using for loop. If you want to write using while loop, you can just do it that while the dimension does not does not cross 3, right? So dimension will go from 0, 1, 2. So as long as dimension is less than 3, you can run the while loop. But it is better to use for loop because you are using nested loops. Nested loops are better executed in for in this type of cases.
Ma'am, is there also do while loop in Python or just
Hello?
while loop?
Hello?
Do while we don't use much. It's while loop only, you have to know. Yeah.
Hello?
Yes, you're audible.
Ma'am, this
Yeah,
this code
continue.
are these code are also applicable in non-square matrix.
So like I said, there you have to change the dimensions, right? There the matrices have different dimensions.
Okay.
So for that, the code will differ a lot. It's not the same. This code is for square matrix. So we can use only one dimension variable. When you have a rectangular matrix, the number of rows and columns will differ. Right? And for to multiply two rectangular matrices, the mathematics is also different. So if you have a 2 cross 3 and a 1 cross 2 matrix, can you multiply them? You can multiply a 2 cross 3 and a 3 cross 4. So the middle order has to match. Okay, so don't go into rectangular matrix. That's a whole different story. We will just work with square matrix. Okay, just keep it simple for now. I mean, you can see that this is already very difficult to understand, right? And this is the naive way.
Okay.
We haven't gone to the functional approach yet.
And this dimension is dim is equal to C is for a resultant, basically.
Yeah, I mean, this is the dimension of the A and B parent matrices also. So resultant matrix will also have the same dimension when you multiply two square matrices.
But
What if we have a 2 by 3 and 3 by 2 matrix? The resultant, we will write the resultant of that as a dimension.
It will be 2 cross 2, but
Yes,
that's a
ma'am.
rectangular thing. Yeah.
Yes, ma'am. We will write the resultant of that thing. Resultant
Yeah,
means
but
dimensions of
see
that.
here the I and j that are iterating, right? Here I can use only one variable for all of them because dimension is 3 in all cases. But if you have 2 cross 3, 3 cross 2, then I value will not work for that 3, right? There will be only 2 rows. So there the dimensions have to change. That's why I said it's much more complicated to write than a square matrix. There are 2, 3 dimension variables. Okay.
In examination, rectangular matrix can also
No,
come.
no, no. Only square matrix will work with.
what kind of questions we can expect in the OPPs or in the
Just check
in-person
out some
exam?
of the PYQs. See, mainly the OPE examination questions will come from the collections. Okay, list, tuple, set, dictionary, from these. Very basic question. Even questions like, see, I'll give you a very small example of OP question. How to find prime numbers in a list? That's an OP question. Right? So you all can write that. Or how to find odd numbers in a list. These are the easy questions. Okay, mainly questions will be easy only in OP1. OP2 questions are very similar. Only in OP2 you will have one of those file questions, but in OP1 there are no file questions, right? So for that I would say you practice the previous year OPs. Okay, all of these things, I mean, we are going to learn a lot of things theoretically than we will be asking in OP. These things are mainly important for your theoretical exams like quiz 1, quiz 2 and term.
Do we have quiz 2 and
No,
interim?
in Python you don't have quiz 2, right? You have entum, I think, only. Quiz 1 and entum.
Do we have interim?
Yeah,
I
yeah,
thought
you have
only
entum.
quiz. Okay.
No, entum is there.
No, I'm not able to solve week 4 GRP2.
Just let me finish this, okay? Because in the next week, in the next class, you are going to discuss all first 4 weeks only. So all of those doubts you can take there. This is week 5, so I'll just finish the summary today.
It's
Okay,
week
and
5.
yeah, this is week 5 we are discussing.
Week 5
Sure.
will come in quiz 1 or
No,
not?
no. First 4 weeks. Okay, so this approach I hope is a little bit clear for you all, right? Don't have
Yes,
to
ma'am.
be all clear, but little bit you understand what is happening. So
Yeah.
main crux of it is that we are using 3 for loops to iterate with 3 different variables where I is iterating among the rows, j is iterating among the columns, and k is helping us traverse the elements inside those rows and columns, right? And for every Cij we need, since here dimension is 3, that means every row and every column has 3 elements each. So to find every Cij value we need 3 multiplications and then we have to add them together. Okay, now this is the naive way of doing it. Now we can make this much more easier on our minds by using a functional approach. Okay, let me do that. So that code will be a little bit more longer. Here, let me get rid of all this. Okay, so first we are going to initialize the matrix. Okay, so let's call it initialize mat. This is the resultant matrix that we want to initialize. Earlier we wrote 0, 0, 0. Manually we wrote all the 0 values, right? Here we are going to initialize with the help of a function. This is more sophisticated code. So dimension, you pass through it. Now take an empty list. C is an empty list. For I in range dimension, for okay, C dot append. So what does this mean? C is the matrix. How many rows are there in my matrix? 3 rows. Or whatever is the dimension, that many rows I have, right? So for every row, I need a separate list because matrix is represented in the form of list of lists. So this is forming the rows. Okay. For every row, I'm adding a separate empty list inside C. Now, now let's populate those lists with zeros. So for I in range dimension, for J in range dimension, Ci, that is inside one row, like inside one empty row, we have to now populate with zeros. So Ci dot append 0. And at the end, you will just return this resultant matrix with all 0 values. Initially, that's what we are doing. So what is this doing? First, we have, so a matrix is what? List of lists, right? It looks like this. See. Initially, this is C, right? Then for I in range dimension, let's take dimension as 3. We are appending that many empty rows. So inside this list, there are now 3 empty rows, like this. Up to line 4, this is what has happened. Clear? Now, for I in range dimension and J in range dimension. So now we have row and column variables. I is row, J is column. So for every IJ combination, we are going to add a 0. Right? In Ci means what? For first row, for second row, for third row. Right? For every I value, I represents a row. So inside every row, for all 3 J values, that is all 3 column values, we are going to append a 0. So after line 7, this will look like 0, 0, 0. Here also same.
Ma'am, can you again explain from line number 5?
Yeah. See. Once the empty lists are added, now you have to go row and column wise, and for every row column combination, that is every IJ combination, you have to add a 0, right? To populate it like this. So if this is row 0th row.
Ma'am, in line number 7, you use only I. Why not J?
Because we are inside a row, right? C. C of I will take me to this row, this first row, right? In the first iteration, when I is 0, then C of 0 is this empty row, right? And then we have to append 0 how many times? As many times this J will run. So J will run 3 times. So 3 zeros will be added.
Then please explain line number 5, 6, and 7. Till 4 it is clear.
Look.
Till 4, the 3 row empty.
This up to this is line 4. Fine. This is line 4. Now come to line 5. For I in range dimension. If dimension is 3, what is first I value? 0. What is first J value? 0.
0.
Now C of I means what? C of 0 means this first empty list. Correct?
Okay.
So C of 0 and J value is currently 0. Append 1 0 inside. Are J iterations over? No. There are 2 more iterations left. So J will be 1. So then also I is still 0. J is 1. Right? For I 0, J will run 3 times. 0, 1, 2. Then I1 again J will run 3 times 0, 1, 2. I2 again J will run 3 times 0, 1, 2. So now I is 0. J starts from 0. So 1, 0 is added. Now J is 1. I is still 0. So the same row we are appending to. Append 1 more 0. Then J is 2. Append 1 more 0. Now J is exhausted. So go for the next I value. So I value is 1. So what is C of 1? The next empty list, this one.
Yes, yes.
Got it?
CO. Yes.
Again 3 zeros. Again I equals to 2 means the next empty list. Again 3 zeros.
Ma'am, in line number 7, if we write Cij dot append 0, then it will
No.
form a
Cij is
inside list.
Cij. So I don't even have a J value initially.
Ma'am, I
Inside.
can understand this, but I want to ask what will happen if Cij dot append 0 in line number 7.
The Cij will not be able to find an index J because inside C of I nothing is there. There are no indices. It is an empty list initially. So there is no index 0, index 1, index 2, right? C of I will take you to the first row like this, which is empty in the beginning. So C of I will take you to this. Then when you go for index J, there is no index J because this is an empty list. So this won't give anything.
Ma'am, in line number 7, if instead of I we use J, then what will happen?
C of J. Then see, if you use J here, then C of J, first J value is 0. So 1 0 will be appended here. Next J value is 1. So 1 0 will be appended here. Next J value is 2. So 1 0 will be appended here. Because only J is iterating. I is not iterating, right?
It is taking J as the...
It is taking J as the list index then.
Okay.
See, when you go for C of 0, see, it doesn't care whether it is I or J. It cares about the index. So J will also start from 0, right? So C of 0 will append 1 0 in the first list. Then it will become, since J value will become 1, so C of 1 will append 1 0 in the second list. Then C of 2 will append 1 0 in the third list. This is not what we want. We want to append 3 zeros in each of the lists. Right, so J is done to append those 3 zeros and I is done to traverse through the rows itself. That's why I said I is the row variable, J is the column variable. Is it clear up to this?
Better than before.
Yeah, ma'am.
See, this part, if it is not getting clear to you, you need to do a lot of dry run. Okay, because you are confusing within this IJ. These things, the iterator variables are confusing you that which one is representing what. That is completely fine. Okay, you take 2 normal matrices like I did and you do a dry run for each line of the code, that how every iteration, what will be the values.
Ma'am, why I is getting like I is taking the row number and J is taking the column number?
You can exchange them, these are just variables.
Variables are there, but why it is taking row number and it is column number? Like,
because it is a list of lists, right? We are representing matrix in the form of list of lists. So when I go for C is an empty list. Inside that I have added 3 lists. So when I go C of I, it will take me through each of the lists inside the empty list. Right? C list has 3 empty lists. So I will let me travel through each of those empty lists. Each empty list represents a row. That's why I'm saying I is a row variable. Now to populate each of the empty lists with 3 zeros, we are using the J variable, which is the column variable. Okay. Okay, so this is just the initialization part. We have a lot to do now. Now we have to write the program for dot product. So I'll write a separate function for that. So definition of dot product. So when I do dot product, I need a row and a column, right? To perform the dot product. Like I did in the previous example. 1 row from A matrix, 1 column from B matrix, and we can do dot product to find Cij. Correct. So I'll take 2 arguments, U and V. U and V represent 2 vectors, or you can think of them as a row and a column, right? A row vector and a column vector. So now inside this, we are going to write dimension. What is dimension? If U represents a row, can I say that the length of the row is the dimension? That is how many elements are in the row is the dimension of the matrix. I can say that. I can also use length of V, because since this is a square matrix, U and V have same number of elements. That's the dimension. The dimension is, let's take length of U. Okay. Now,
Ma'am, if it was rectangular matrix, then would we take U or would we take V?
that is a whole different thing. Then the dot product won't work like this. For dot product, you need equal number of elements in each row and each column. Okay. Otherwise, dot product can be performed. This is also there in maths if you have studied vectors. Dot product, cross product, those are two different things, right? Dot product is only applicable when you have same number of elements in both rows and columns. Okay. See, we are trying to calculate that Cij that I had written previous code. That Cij value. So now in answer, let's take answer. In this, I'm going to store the dot product. So answer is initially 0. For I in range, how many I values are there in the, that is how many row values are there? 3. So dimension, I in range dimension. Answer. So this is the part where it becomes simple, right? Now you don't need those 3 nested for loops. Now I can do it in one loop. Answer will be equal to answer plus U of I cross V of I. Why this happens? See, this will just return answer. Now relate this code.
Can I ask you a question?
Two vectors, U is the row vector, V is the column vector. So if not 3, V is the first column, this one. So V is like this. Okay, let me write it in the form of a row maybe. 10, 13, 16. This is U, this is V. This is the row vector, column vector. Okay, we are just taking them as vectors now. So I wrote the code that for I in range dimension, that is I will range from 0, 1, 2 if dimension is 3. In every iteration, what is happening? Answer is equal to answer plus U of I star V of I. Now calculate this from this.
Ma'am, can you please explain second function again?
That's what I'm doing. This is the second function. I'm just writing the dry run. See, this is the code. So in second function, we are trying to find the dot product. For dot product, we need what? One row, one column. Right, so that is U and V, 2 vectors. In dimension, we are storing the length of either of them because they're square matrix, same number of elements in U and V. So if dimension is 3, now answer is the variable in which I'm going to store the dot product. So answer is initialized to 0, like Cij. So for I in range dimension is 3, then I will run how many times? 3 times. I0, I1, I2. That's what I'm showing you now. What are the iterations going to look like for these 2 vectors? Okay, so what is U of I for first iteration where I is 0? What is U of I?
U of I is 1.
1. What is V of I?
10.
Ma'am, V is not a column. It is a row.
But it is taking in the form of a column only. I'll show you how. Okay, for now, think of these 2 as vectors. Don't think of them as rows and columns. Just think of them as vectors. Okay, how we do that is in a separate function. Just think of them as vectors. We will extract the row and column. Okay, we will extract the row and column separately. But these are now both in the form of lists like this. Okay, just focus on these things now, that these are U and V are row and column vectors. We need to find dot product. So U into V, U of I into V of I is 10 plus next I value will be 1. So U of I is 2, V of I is 13. So 10 plus 2 into 13 plus 3 into 16. So this is again giving what? What is this giving? Same 84. That is the P00, this element. Now this particular function that we wrote, this dot product, is to just calculate this dot product. How we got U and V, that I'm going to discuss now. Okay, but I hope the dot product is clear, right? If we have 2 lists, we can calculate a dot product.
It is clear.
Okay, now the part of how we got U and V. So for that, I am going to extract every row and every column. So first, let's write the function for extracting a row from a matrix. So let's say I want to extract row I from matrix M. So in the definition of this function, take M matrix and ith row as your parameters. How to do it? Dimension again. Dimension is same as length of matrix M. Length of matrix M means what? Matrix M is a list of lists. So how many inner lists are there for dimension 3? 3 inner lists. So length is 3, dimension is 3.
Could you please repeat this particular segment? I couldn't follow 17 and 18.
What is M? Matrix. Matrix is represented in which form?
Rows
list
and
of
columns.
lists.
List of lists, okay.
So M matrix is one big list inside which there are 3 small lists, each representing a row. Right?
Yes.
So length of M is what? 3.
Okay.
Length of a list is the number of elements in it. So
Okay.
there are 3 elements, 3 inner lists. So dimension is 3.
Okay, so just to confirm my understanding, a matrix has list. It's a list of lists, right? Each row is one list. So here you're defining M means that M is one matrix. And what is this I? I represents the number of
I is the
rows that
row
it
that
should
I'm
contain.
trying to extract. I is the
Okay.
row that I'm trying to extract.
Okay,
Yeah.
okay, thank you.
Okay, now see, I'll take a list, empty list L. In this, I'm going to do the extraction. Okay, like I said, that U and V vectors, how they're forming. Now, see, this is how I get the row vector or the row. So L is an empty list. Okay. In M matrix, I want to extract ith row. So here I will run a for loop for k in range dimension. K in range dimension. L dot append M of k of j and return L. So what's happening here? Up to this it is clear, line 19. Right? Up to line 19 it is clear.
I'm giving a matrix
This is
M.
I. I'm sorry. This is I.
Ma'am, why you take line 90 empty list?
That is where I'm extracting the row out of the matrix. This is the row I'm going to return. That currently if I want to find dot product of row U and row V, so that row U has to be extracted from the matrix, right? That extraction is done in this list L. I'll show you. Once all the definitions are written, then you will be able to put together the entire picture. But for now, just bear with me and see this. Row definition of this function takes 2 parameters, matrix M and I. I means what? The ith row that I want to get from here, that I want to extract from this M matrix. How are you extracting that? You have the dimension, you have an empty list L. In the for loop, k is ranging from 0, 1, 2. In L list, you're appending what? M of k of I. Here, which value is fixed? Which value is iterating? K or I? Which one is fixed?
I is fixed, K is
I
iterating.
is fixed. Let's say I want to extract 0th row. So I is 0. Right? I is 0. So K is going to be what? 0, 1, 2. Okay. Actually, this is for column I have written. This should be I, K. So I is going to be the row, and then K value is going to change from 0, 1, 2, because inside each row there are 3 columns, 0th column, first column, second column. We need all 3 values. See, now relate it with this example. This is way too messy. Let's go to the next page. If this is my matrix M, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Dimension is what? 3. We have empty list L. For k in range dimension, what are we doing? L dot append M of ik.
Now let's do the iteration wise process. First iteration, what is I value? I value is fixed as 0. I am saying that I want to extract 0th row. K value is what? 0 in first iteration. What is m of ik here?
1.
This m of 0, 0, that is 1. It is being appended to where? L list. So now L has what? 1. Second iteration, I still remains 0. What is K?
K1
So
results into 2.
Right. So m of 0, 1, which is 0th row, number 1 column. So this. So now that is added to L. Now L becomes 1, 2. Third iteration, I is still 0, K is 2. So m of 0, 2, that is 0th row, second column, that is 3. Append 3 to L. So L is now 1, 2, 3. This is the first column that I'm trying to extract, and that is being returned by the procedure row. Is it clear? How it is being extracted each row? Is it clear? For any row I can do this, for any I value. Which part you're not understanding? Tell me. So this is okay for everyone. Should I go to the next procedure, column 1? Now, if you understand this, then you can write the column 1 yourself. Tell me what should be the way of extracting a column then. You know how to extract a row. Now try using that logic. This is the whole point of me writing this code. Right? We can very easily do this in 2 lines using the NumPy library. But the exercise, the point of doing this exercise is to build your logic. So now you know how to extract a row. Now you tell me how to extract a column in the same way. Only one thing will change. What is that?
Ma'am, we have to take J in line number 17, then KJ in line number 21.
KJ. Correct. Because then the rows will change, right? The column is fixed. So inside one column, there are 3 values, one in row 0, one in row 1, one in row 2. But the column is same. That means J value will be fixed and K value will change. So it will be M of KJ. So let's just copy paste this. Let's name this procedure as column. This will take M and J. You can use any variable. Here only the change will happen. This is K. This is J. Okay. So this will extract a column. Should I do the dry run? Or you can understand? Okay. Since you're not giving a response, I'll just do the dry run. See. Here also we have an empty list L. For first iteration, J will be fixed here. J is 0. Let's say I'm trying to extract the first column, this column. So J is 0. K value, first iteration, it is 0. So what is M of Kj? That is M00 in this case. 1. So append it to L. Second iteration, it is M of 10. That is 4. Append it to L. 1, 4. Then third iteration, it is M of 20. Row 2, column 0, which is 7. Again append it to L. So 1, 4, 7. So this is how the column is extracted. Now you can see that these are both in the form of a list. That's how we were able to find the dot product using both lists. You were confused, right? That one is row, one is column. How can we write that? Because when we extract, we make it into a list. Up to this, is it clear for everyone? Yes, no, any answer? Wait, am I not audible? Okay. I think I am audible.
Ma'am, I'm not understanding actually.
Okay, tell me which part you're not understanding. That Up to this dot product, did you understand?
No, ma'am, dot product.
Okay,
Also, I didn't understand.
just tell me this. Did you understand how to initialize the matrix, the resultant matrix, with all zeros?
Yes, that I understood. 50% I understood. Yeah.
Okay. See, in this procedure, row and column, in these two, we are just trying to extract the row and the column that we need to create the dot product.
Yeah, yeah,
We
that I
need
know.
one row and one column for a dot product, right? So how to extract that row? That is being done here. So that's why I did the dry run to show you how the row is getting extracted. See again. This is my matrix M 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is matrix M. I want to extract this row, let's say. Which row is it? Row 0, right? So now in the code that I wrote, what are the steps I have written? I need to store the dimension. I need an empty list where I will extract. And then I will run a for loop k in the range dimension and append each m of ik to that list. That is how I'm extracting. So now let's see what it actually does in the program. Dimension is what? This matrix has what dimension?
3.
3. I have an empty list L. Remember, in L, I am trying to store this first row that I'm extracting. So for k in range dimension, L dot, this is the code, L dot append m of ik. Now let's write each of the iterations of this for loop. For the first iteration, see, I am extracting 0th row. In the code, you can see I have passed two parameters, the matrix and the row that I want to extract, I. So I is fixed. I know I want to extract the 0th row. So here I will remain 0 for all iterations. Now do the rest. For first iteration, what is k value?
0.
If dimension is 3, what is k value?
0.
0. So first iteration, I0, K0. What is m of ik? That is m of 0, 0. What value is that in this matrix?
1.
1. This one. Append it to L. L dot append m of ik. So now L contains 1. Up to this, is it clear?
Yes, ma'am.
Now in the second iteration, see, I is fixed, I is 0. What is k? 1.
Yes, ma'am.
Right? What is m of ik? M of 0, 1. Tell me
2.
the value.
2.
2. Append it to L. So L becomes 1, 2. Now
Yes,
third iteration, I is still 0. I is the parameter I've passed. I value is not changing. It is not a loop variable. Only k value will change. K is now 2. M of ik is now m of 0, 2, which is 3. 0th row, third or second column, in this case 0, 1, 2. So column number 2. That is this value. Append it to L, it is 1, 2, 3. At this point, if I return L, is it the correct row extracted?
Yes, ma'am.
Okay, so this is your row function, this one that I wrote. Clear?
Yes, ma'am, clear.
Now, if you want to do the same for a column, if you want to extract a column, right, there is only one change, one line change. If I want to extract this column, let's say column 0. So now I will pass j equals to 0 as the parameter. That is, j value is fixed. I want column 0. Which value has to iterate? The row.
Row.
Right? Because there is one value of column 0 in row 0, one value of column 0 in row 1, one value of column 0 in row 2. So same iterations will happen, except now in L dot append, I am adding what? M of what is fixed? J. It is the column is fixed. The row is flexible. So M of Kj. Now for first iteration, see, j is now 0. J is fixed. I want the first column. So for first iteration, what is m of kj? What is k value in first iteration? K is 0. So kj is m of 0, 0, which is 1. So L dot append m of kj. So L is now 1. In second iteration, what is k? 1. M of kj is m of 1, 0. That is row 1, column 0, 4. Append it to L. L becomes 1, 4. Third iteration, k is 2. M of kj is m of 2, 0. That means row 2, column 0, which is 7. So this is going to give 7. Append it to L. L is now 1, 4, 7. Is this the first column we are trying to extract? 0th column?
Yes, ma'am.
So row and column procedures are clear to you?
Yes, ma'am. Now clear.
Right. See, why am I doing this? Because to find the dot product. Now that I can extract each of the row and each of the column. See, what did we extract? We extracted the 0th row and the 0th column, right? Now, if I want to find dot product of these two. So now come to the dot product. Here U and V, these are the two lists we just extracted. U is the row list, V is the column list. So now can I not just do a simple dot product of them using one single loop I? I will go through each of the elements in the corresponding lists, that is U0, V0 is a product, U1, V1 is a product, U2, V2 is a product, and then add them. That is the same dot product, right? Row into column. Okay.
Ma'am, what you say, I am not able to understand.
Okay. This is
the last part.
This is U. 1, 2, 3, the row I extracted. V is the column I extracted, 1, 4, 7. This is clear up to this?
Yeah, ma'am, that will simply give only one place value, not whole M matrix.
One place value only we are trying to find. The dot product function will be called every time we want to find a place value Cij. Okay. For that we need separate row, separate column combination, right? I'm just trying to make you understand what each of the procedures do. Then we are going to combine them all together. Okay. So now when we find the dot product, this 1 and 1 are going to be multiplied, 2 and 4 are going to be multiplied, 3 and 7 are going to be multiplied, and then these products are going to be added. That's your dot product. Now that we have all 4 procedures completed, okay, now we are going to write the actual procedure of matrix multiplication, where we will call all of these procedures that we just wrote, or functions. So definition of matrix multiplication. It will take 2 matrices A and B, right? 2 matrices A and B. Dimension is what? Can I take length of any of the matrix A or B as dimension?
For square matrix only.
Yeah, we are doing this entire thing for only square matrix, no rectangular matrix. So length of A is the dimension, or length of B is the dimension. Now initialize the resultant matrix. So to initialize, which procedure will I call?
Initialize mat.
This will initialize resultant matrix C, and all values in that matrix will be what? 0. So call initialize mat with the same dimension. Now your resultant matrix is created. Now we need to populate it, right? So for I in range dimension, for j in range dimension, again, see, these are row and column variables. C of ij, that same thing. So here also now write C of ij, that is each of the place values in the resultant matrix. How will we calculate? Now we don't have to write that logic anymore. We already have all of the components. So we need to find dot product, right? We need to find dot product. How will we find the dot product? Which procedure should I call?
Line number 10.
Dot product. So write dot product. Now u and v, that means each of the extractions. First extraction is u is the row extraction, v is the column extraction. So how do I extract the row? Using which procedure?
Here, ma'am, we have to use I instead of U.
No, just tell me, to get the extracted row u, which procedure do I need? Which function do I need?
Ma'am, 17.
Row. Okay, just the function name, row. So row, and what do I pass? Matrix A and which row? I. This is a loop. We need all possible ij combinations. So row of a comma I. This is the first row we are going to extract. And what column am I going to extract? For that, what procedure or what function is there? Column function is there.
24.
So write column. What am I passing? Matrix B, comma. Which row you want to extract? J.
J.
So this is your dot product. Now for every ij combination, it will extract the corresponding row, corresponding column, and form the dot product and populate the Cij place. Now after this is done, so this is the population of the matrix. Come out of this for loop, both of the for loops, and just return the resultant matrix C. Is this clear for everyone?
Yeah, ma'am.
Right. This is better than the previous one because now we have every component separated and we understand how the extractions work. Okay, other than if you didn't want to do this, you would have to do that 3 for loops, and that increases the
Ma'am,
time
it is clear now, but I am not able to write it in one go like you.
It won't be possible. No, I have done this multiple times. You are the first time you're learning it. It will take you time. You learn, do it on your own speed. It's fine. But you have to understand the logic. That's all. That's all I'm asking. From this class, you just understand the logic. You don't have to write the code right now. Okay. Logic is clear, right? Now, okay. Let's try to do it using, let me give 2 matrices. So let's take matrix A, which is, just to test out if this is working. 1, 2, 3, 4, 5, 6.
Ma'am, in last, we do not need to write any print statement.
No, that is when you call the procedure. That's why I'm writing this. I will call the procedure and then I'll print the value. Okay. These are just functions. They don't need to print anything. They just need to return the value. That's it. Print is when you're calling any of these procedures. Then you need the print. Okay.
Can you please explain last line again, ma'am?
Which line?
What you say about print statement?
I'll tell you. Just let me write the 2 matrix from which we are going to do the multiplication. Then you'll understand yourself. Okay. This is 1, 2, 1. We'll take 3, 1, 7, the second row, and last row is, let's take 6, 2, 3. These are both my matrices. Fine. I want to do a matrix multiplication on them. Which procedure will I call? Which function will I call?
The last one.
Matrix multiplication, this one. Okay. So here you have the print statement, right? Print of matrix multiplication and pass A and B. Now if we run this, okay, something is not closed. Okay, here one bracket I missed.
So this is the resultant matrix in the terminal. See this one. So now check it for yourself. First row and first column, do it. First row is 1, 2, 3. First column is this one. 1, here 3, and we have 6 here. So do the multiplication 1 into 1, 1. 2 into 3 is 6. 1 plus 6 is 7. 3 into 6 is 18. 18 plus 7 is 25. So 25 is the first element in the resultant matrix. So this is working. Okay, here when you are calling the procedure matrix multiplication, then you can print whatever it returns, which is the resultant matrix C. Clear? All of you?
Ma'am, can we not write print statement directly in line number 38? We are not want to define.
This is a generalization, right? You are, yeah, you can do it. You can write print C. Okay, it will print it right here. But it is good practice that you don't print inside the functions. You print when you are calling a function. These are just function definitions. Right, good practices. When you're using a function, then it returns something that's a meaningful value to you. So you print it then separately.
Ma'am, I am printed separately, but I ask that we have to define line number 39 or 40. It is not necessary.
No, you can take user input. Here I have defined. You can also take user input. Take 2 user inputs for 2 matrices. List of.
Ma'am, how to take list inputs? Input for string is directly input. Input for integer is.
Input for list is not discussed. Now, all of you haven't done this part. How to take list inputs?
No, ma'am. No, I am not understanding it. I am able to understand integer input directly, string input, but not list input.
List input takes eval. Okay, eval is, that's a complete new thing. If I knew you did not know this part, then okay.
How to take list input from anyone else?
See, one easy way of doing is that if you just want to enter elements and then split them, that way you can take a list input. Right here you can write it like this. I'll just show one line. I'm not going to discuss this. It's a big thing because there are different ways of taking input. All this should have been discussed when you are discussing lists, right? I thought this was covered, but I'll just show you one way of taking input. Okay, how to take list input. You can use the split method. Split method everyone knows.
Yeah, ma'am.
And which method?
Split.
Split.
Split method in Python. What does split do? Split method separates the input based on whatever you give in the parameter. It can be spaces, it can be commas.
And from the
user input.
It works on the string, no, man?
Yeah.
Can you little elaborate it? Give a little example.
See, if I take input like this, 1, 2, 3. Okay, let me write the whole thing then. See, let's take a different example here. In L, okay, I'm trying to take a list input. This is one way of doing it. Write input. Here I'm going to write enter elements separated by space. This is how the split method will work. Okay. So enter elements separated by space and then do a dot split. So wherever in your input the compiler will find splits, or that is spaces, it will split the values according to the spaces. And print list L. So now if you run these 2 lines, okay, so enter element separated by space, I can enter it like this, 1, 2, 3, 4, 5. So this is a list input now. Understood?
Ma'am, can you please explain split here?
See, it's very simple. Enter elements separated by space. I entered 5 elements, there are spaces in between. So wherever it is finding a space, it is splitting there. That means it is putting a comma over there in the list. That is, this is the end of one element. A space means an element has ended and you are going to the next element. So in the list, it will put a comma over there. After one, it finds a space, so it forms a split, and there is a comma after one. Then two comes.
Ma'am, I used to split bracket comma for it.
Yeah, that also you can do. So if you
We
enter the
can
value
directly use
comma,
we if we don't use comma inside bracket, it also fine.
in list the elements have to be separated by comma, right?
Okay, that's thank you, ma'am.
Okay. This is one way of having a list. Okay, but there are other ways of taking input also. You can do
Ma'am,
int input also.
Ma'am,
Eval also is there.
inside the argument of split, we have the space.
There is nothing. There is nothing means space.
Nothing means space. Okay.
Yeah.
If we want hyphen, then we should enclose.
Any character you want. Yeah.
Then we should enclose between inverted commas.
See, here you can put comma also, right? Like this. Now it will split according to commas. So in the input you have to give the commas.
Okay.
Okay, but eval is one of the most popular methods of taking list input. All of this should not be discussed so late. I thought all this was done.
No, ma'am, no one discuss, even the mentors and TH, no one discuss it.
Okay, see,
even professor lectures don't mention about that.
List input is not discussed. Okay, fine. Because see why this is done, because in the OPs also and everywhere we don't usually ask you to take user input. You just have to write the function. That's why most of these things are skipped, but it is always good to know, right? So let's write one more way and then I'll let you go because you have one more class, I think. See.
Ma'am, can you show those last two lines again for screenshot? Yeah, ma'am.
Okay. See, one more thing we can do is actually eval. To do this, you need to know other things also. Okay, it's okay. You just keep this in mind for now. Let's do the split for now. Eval one I'll discuss or what whoever.
Ma'am, how to find these in Gemini? How we can find using Gemini about these?
I use books. I mean, if you're using AI, I don't know. You can use ChatGPT, I guess. You can ask that how to take list input. Just simply like that, it will give you all the input, different ways of taking input. Okay. So how to take list input in Python, you can ask. You'll get all the ways. But yeah, we'll discuss this also in the next class. I think you have quiz 1 revision, right? So lists and all will be discussed. I'll tell the instructors to discuss this part once. Okay.
Sir, ma'am, when this division session happens, the day?
The next session, I don't know. I think it's Friday or Thursday. Thursday, I think. Yeah. Okay, but see, I was supposed to discuss a lot more today. We only got very few things done. Matrix multiplication took a lot of time. But there are a lot more other things in this week. Like we did not get to the part of iterator, generator, lambda functions. Those are very important for OPE point of view. So we'll try to cover those in the next session. Okay. But for now, you focus on your quiz and do the first 4 weeks.
Ma'am, this week GRPs are also very heavy, ma'am, actually. Week 4.
Yeah, of course. See, it will get difficult only from now onwards. Okay, so GRP and all, whatever doubts you're having, the revision sessions are all for that only. You can ask all your doubts. Okay, there will be TA sessions also. Okay.
Ma'am, tomorrow session is a revision session by TA.
Yeah, I think tomorrow is revision session. TA revision, but there will be 2 instructor revisions also. Okay. So, yeah, I think that's my last class before quiz 1. So, yeah, all the best for your exams. We'll meet after quiz 1.
Thank you, ma'am.
Thank you.
Thank you.
Thank you,
Happy
ma'am.
Diwali, ma'am.
Happy Diwali.
Happy Diwali, ma'am.
Happy Diwali, ma'am.
भैया